All right, so what I'm going to do is I'm going to prep you for the acid-base test. If you pay attention, I'm going to make scoring on that test very, very simple. So that's basically what we're going to focus on. So the first thing is, first question says, which one gives the lowest concentration of anions? Well, think about this. This is an ionic compound, so it's going to break apart completely. This is a weak acid. This is an ionic compound. This is an ionic compound. The fundamental definition of a weak acid is it breaks apart less than 5%. So this is going to produce the least amount of ions because it's a weak acid. Okay, so keep that in mind. So that's important to know. So the fundamental definition of weak acid, like if you're comparing acid strength, we say a strong acid breaks apart completely. And so if it breaks apart completely, you're going to get lots of H+, which means my pH, the strongest acid, is going to have the lowest pH because the concentration of H+ and pH are inversely related. Whereas if you take a weak acid barely breaks apart. So most of it stays together, and let's say it breaks apart less than 5%. I get very little H+, so that means my pH will still be acidic, but the pH will not be as low. So keep that in mind when you're comparing pHs of weak acids and strong acids. It makes a difference. Next question says, what's the pH of a solution of barium hydroxide? They love to use barium hydroxide on the AP exam because you get the double A. Woot, woot, woot. You get double the OH. So the first thing I have to do to this is multiply the molarity times 2. So I'm going to go 0.0005 and 0.0005, add it together, I get a molarity of 0.0001, not molarity of OH minus. Now I know what you're thinking. How do they expect me to do this without a calculator? Scientific notation rocks on this test. So we're going to go 1.0 times 10 to the negative 1. Did I do that wrong? Should be 3 zeros. 1.0 times 10 to the negative 4th. So when I added it together, I didn't add it exactly right. So there we go right here. I put in scientific notation because it should be there. That should be a 0. What I do to take the negative log without a calculator is I just put in scientific notation, grab the exponent for it, and then basically flip the sign. So then if I have OH concentration, if I took the negative log of that, I would get POH. So I grab the exponent, and my POH is 4. If my POH is 4, remember POH plus pH has to equal 14. That means my pH is going to be 10. So all you have to do on the exam is pay attention to the BaOH2. Also, put it in scientific notation, makes it easy to score. Next one. HC is a weak acid, so they wanted us to calculate Ka. They're going to have you do x squared over molarity equals Ka problems on multiple choice without a calculator. The trick is scientific notation. They tell me I have 0.02, so if I go 0.020 moles in 1 liter, because it says 1 liter solution, technically my molarity is 0.020 liters. But that ain't going to work for this. I'm going to change into scientific notation. So I'm going to go 2.0 times 10 to the negative second goes there. They also tell me my pH is 5. Now remember, going out, normally we go pH, we go 10 to the negative 5.0. Without a calculator, it's easy because it's an even pH value. That just means my pH is going to be 1.0 times 10 to the negative 5th. Because keep in mind, you grab the exponent when we negative log it. When we come out of it, this just becomes our exponent. So to go from pH to the H+ concentration, so ultimately that means I have 1.0 times 10 to the negative 5th, and that's going to be squared on top. So all I have to do is the math. First little trick is when you're squaring stuff in scientific notation, the front number can just get squared. So 1 squared is going to be 1. When I go to square an exponent, I'm just going to double it. Add it together basically when I multiply. So negative 5 times negative 5 gives me 1.0 times 10 to the negative 10th. The bottom number is still good to go. Let me see if I can grab it and move it. The bottom number is going to be 2.0 times 10 to the negative second. I don't know what just happened there, but sweet. So then I just have to finish the math. Well, when I divide in scientific notation, I divide the fronts, or the mantissa. I'm going to 1 divided by 2 is going to be 0.5. What I do is I subtract the exponent. So I'm going negative 10 minus a negative 2, which is going to give me 10 to the negative 8th when I'm done with that. This is not incorrect scientific notation, so I swing it back over, and that's how I get D. It is critical you put them in scientific notation. That's the only way you're going to be able to do these, and they expect you to do 1 or 2 of them on the exam. Which of the statements regarding kW is false? Well, the value of kW is not always 1.0 times 10 to the negative 14th. See the always there? It changes. Because think about this. Water breaks apart, autoionization, into H3O plus and OH minus. So what happens is, and it's an endothermic process, which means heat is here. So if the temperature goes up, we Lachad it a little bit. What it's going to do is it's going to drive it this way, and you're going to get greater amounts of H3O plus and OH minus. It's not going to make water more acidic, because acidic or basic is when they're not equal to each other, because these things will still be equal. But what it will do is cause the kW value to change. So the kW value will change, and the amount of OH and H3O plus will increase as well. The amount of H3O plus increases and OH increases, and if they increase at the same rate, it doesn't really change it. It doesn't make it an acid, but the pH value will change. Okay, next. 11. Which of the following substances will form basic solutions? They ask us all the time. Whenever it asks you basic, pH, acid, the first thing you do, your first move is kung fu wise, is cancel any heartbreakers. Cl is a heartbreaker, leaving NH4 plus. Positive ion, that means that's going to be an acid or act as an acid. NO3 is going to leave Cu2 plus. That's going to be acidic in solution. I'm going to cancel my K, leaving CO3 2 minus. That's going to be a base. Negative ion is going to be a base. Na cancels. F minus is going to be a base. Remember, negative ions are going to be basic or conjugate bases. Positive ions that don't cancel are going to be acidic. So when they're asking who's going to be basic in this one, in 11, the correct answer is going to be D. Those are the ones that are going to be basic. Next one, 13. They ask you pOH of a solution. Now, if I cancel this, it's an ion. They rarely do this in the multiple choice, but they could ask you this in the free response. So if you notice, a negative ion, we already talked about, a negative ion takes an H because it acts as a base, according to Bronsted-Lowry. So what we're going to get is we're going to get OH minus plus HNO2, right? Now what we have to do is, it's the same idea. It's going to be x squared over molarity, except when it's an ion, we have to calculate K. That's the only difference. So I'm going to take my molarity, put it into scientific notation, because that's basically how we're going to have to do all this. Get it basic? Anyway, what I'm going to do is I'm going to take my Ka value, which is going to be 5.0 times 10 to the negative 4th. Now remember, Ka times Kb equals Kw. So my Kw is 1.0 times 10 to the negative 14th. And I have a Ka, because this is going to be basic, so I need a Kb to solve for this. So I'm going to put my x on top. That means I have to take 1.0 times 10 to the negative 14th divided by 5 points. So I'm going to go 1.0 times 10 to the negative 14th divided by 5.0 times 10 to the negative 4th. Well, 1 divided by 5, that's going to be 0.20 basically. And then I'm going to get 10 to the, now what do? I'm going to go, whenever I divide in scientific notation, I'm going to do negative 14 minus a negative 4, which ultimately is going to give me 10 to the negative 10th. Except, I'm going to slide that sucker over, move it over there, and ultimately I get 2.0 times 10 to the negative 11th. So now I'm all set to solve it. So I'm going to clean this up real quick because I converted my K. I got my K calc. So it's time to rock and roll. Now, I'm going to multiply in scientific notation. Remember, it's designed to be done pretty easy. 2 times 2 is going to be 4. Negative 3 times plus a negative 11, I'm going to get negative 14th. So I'm going to basically get that, and then what I'm going to do is I'm going to have to take, that's going to be equal to x squared. So then what I'm going to do is I'm going to take the square root of that. Well, in scientific notation, if I have to square root something, that's easy. The front number is going to be 2. I just have, when I square root it, I just have what the exponent is. So the negative 14 is going to be 2 to the negative 7th. That is my x, or my OH concentration. How do I take the negative log of that? All I do is look at that and flip the sign and look what's close. Remember, the AP exam is designed for you to be able to round it a little bit. In this case, you have to use it in scientific notation, but it's designed for you to have disparity between the answer choices. So that's how you'd solve that one. Next one, 14. 0.1 molar solution of acetic acid. First of all, acetic acid you need to know is a weak acid, right? So pH of a weak acid, if you even had to guess, has to be between about 2 and 6, roughly, right? You know it can't be 14, it can't be 10, and it can't be 7. So you have these two answer choices. Let's say I decided to put it in scientific notation, 1.0 times 10 to the negative first. Now that's a weak acid, so it's only going to ionize about 5%, right? Which means that answer doesn't make sense. If I had HCl and my concentration was 1.0 times 10 to the negative first, and I took the negative log of that, that would be 1. So the only way that could be 1 is if that was a 0.1 molar solution of a strong acid. You know acetic acid is weak, so when you think about it, you can already eliminate answer choices that don't even apply. So the correct answer is going to be a pH of about 3 probably. You're just estimating in that case. 15. Ka for this is 9.4 times 10 to the negative fourth. What is the percent dissociation? Well, remember it's another x squared over molarity is equal to Ka. Now when we go to do percent dissociation, it's x over the original molarity times 100. So the first thing we got to do, since we have molarity, is 1.0. I'm going to put it right there. 1.0 is right there. I have that. I need x. So I'm going to solve for x. And again, scientific notation rocks. So I'm going to go 9 times 10 to the negative fourth is my Ka. My molarity I'm going to put into scientific notation. I'm just going to go 1.0 times 10 to the 0. So it's the same number, x squared. I'm going to go 1 times 9. I'm going to get 9. And then I'm going to add 0 plus a negative 4. I'm going to get 9 times 10 to the negative fourth is equal to x squared. I got to take the square root of this. Again, it's got to be easy. Square root of 9 is 3. I take half of that is going to be to the negative second. So x is going to be 3 times 10 to the negative second. So if I come over here, I would do this. I would go over here. If I'm popping in my formula, I would just do this. I would go 3 times 10 to the negative second, or 0.03 over 1 times 100. That's going to get you 3%. That's going to be 3% ionized. That's the percent ionization. So again, it goes back to x squared over molarity is equal to Ka. You must use psi notation. It's designed to be done very quickly in scientific notation, but you got to write it out. Don't be a gangster. 19. This occurs on the exam every year. They tell you the above equation has an equilibrium constant that's less than 1. So if the K value is less than 1, what does that mean? I don't even know what I just did there. I just reverse that. I just drag it. No, I guess that's not possible. See if I can delete that. So check it out. Here's how it works. If it is less than 1, if K, remember, if K is less than 1, basically, right? If K is less than 1, if K is less than 1 here, like here. If K is less than 1, what does that mean? That means that K is going to be less than 1. So what that means is you have the species that is going to be mostly present is going to be the reactants. So the reactants are going to be present, which means that what happens is it's favored basically to go this way. It's reactant favored, which means it goes this way, which means in terms of acids and bases, this has to be a stronger acid, and that has to be a stronger, that's an acid, and that's the conjugate base, because going this way it takes an H. That's how you can tell the difference in the strength. So since the reactant side is favored, that means this side, these two things have to be stronger. Whichever side the K points to, the opposite side means it's going to be stronger with acids and bases. So that means HiO3 is going to be stronger than HC2H3O2, and IO3 minus is going to actually C2H3O2 minus is going to be greater than IO3 minus. It's weird the way that's written, but D is the correct answer. So you have to know that. They ask that on the exam every year. Whichever side the K favors, circle it. Opposite side is going to be stronger. Look here, same thing. Equilibrium constant for 22. K is 7.2 times 10 to the negative second. This is the favored side. Whoa. This is the favored side right here. That's going to be the favored side. So what does that mean is these are going to be stronger. So let's see. Concentration of HC3, H5O2, and HCO will always be equal. No, that's not true. C3H5O2 is a stronger base. True, because it's on the side. Boom. There you go. 22 is B. That is not a stronger acid because it's favored, the reaction's favored to stay on that side. So there you go. That can't be a stronger base either. Piece of cake, that one. That's going to be on your test for sure. 25, strong acids. The definition of a strong acid does not have equilibrium lying far to the left. It goes to completion. So if we take HCl, we drop it in water, you're going to get 100% H3O plus and Cl minus, 100%. When it says completion, when you hear that term completion, it means you get all products. Whenever you read that on any, and there's going to be test questions on Monday, completion means you go this way, 0 of this left. So if I started with 1 molar of this, I would get 1 molar of this and 1 molar of this, and this side's going to be 0. So really, B is the correct answer. They call it this person calls it a pathetic conjugate base, but we call it a heartbreaker. It means they don't want to get back together. They basically have no reaction with water. Have a conjugate base which is stronger, not true. Readily move H plus ions from solution, not true. They drop them in there. Only slightly disassociated, wrong. Completely disassociated, they go to completion. So on the AP exam, it says completion means all products, no reactants. 26 says, when calculating the pH, blah, 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 from its concentration, why do we ignore why the contribution of water? Because we know water naturally breaks up into H3O plus and OH minus. Why do we ignore that value? Well, because the amount it actually produces is so low, we basically can just ignore it. Not because it's a weak acid or it can dissolve glass. It's simply because the water does break up in H3O plus and OH minus, but it's so minute the amount it produces, it doesn't really matter. Next one. We got a 4% disassociated at 0.1 molar Ka. So when we go to do a Ka, remember it's going to be x squared over molarity is equal to Ka. I'm going to take the molarity, I'm going to go 1.0 times 10 to the negative first. And then I'm going to go, I have to get the concentration on the top, x squared. It says it's 4% disassociated. 4% as a decimal is that, right? So what I would do is, as a decimal, I would just change it into side note. So I'm going to go 4.0 times 10 to the negative second. Yeah. And then I'm going to multiply that times the molarity, which is going to be 1.0 times 10 to the negative first. So 4 times 1, I'm going to get 4 up here. 4.0. Add the two together. It's going to be 4.0 without a calculator. It's going to be 4.0 times 10 to the negative third. Then I got to square that sucker because it's x squared. So if it says it's 4% disassociated, you're just taking 4% of that. But that's where just put in scientific notation. It makes the exam very simple. 4 divided by 1. Last time I checked, that's going to be 4. Oh no, whoops. Oh, did the math wrong. Busted. Nice try, bruh. Let's try squaring it first. Little mathematics there. That's going to be 16. And then I'm going to add the two together. So I'm going to get to the negative. That's going to be to the negative 6. I got to put it back in regular scientific notation. So I'm going to slide it back over there, which is going to give me to the negative 5th when I slide it the other way. So I put it back in regular science. You can wait to do it too. It doesn't really matter. So I get 1.6 times 10 to the negative 5th. Then I get to divide by 1.0 times 10 to the negative first. 1.6 divided by 1, I'm going to get 1.6. Negative 5 minus a negative 1 is going to be to the negative 4th. So then I'm going to end up getting B as my correct answer. Just remember to do everything in scientific notation. It basically makes the exam easier to manipulate. It's designed to do it that way, and the numbers are easy. So this is part 1. I'm going to record part 2 and get you ready for your test tomorrow.